told you or reminded you about the change in position? Yeah, if I said what's the antiderivative, you would say s of t. And how do you evaluate that? You do s of b minus s of a, right? The fundamental theorem of calculus. To find something's final position, what we have to be given or know is where it started. So we need to know its initial position, which we would call s of 0. And then we would need to know its integral from, I guess it would be 0 to b, wouldn't it be? In this case, we've talked about how you could do this with any different variable. Like if this, maybe if it was a, I would have to know what s of a was plus the integral from a to b, v of t dt. Okay, so we can do this from any point. If we know the position at a certain time, we can start that time and then calculate the displacement after that time. To find total distance traveled, that's different. Do you guys remember what we have to do for that? But then, which is the integral, but what if it's negative?
Absolute value?
Yep, now make sure you put the absolute value in or after the integral. That's important. The reason why that's important is because if you did the integral first, what it would do is it would calculate the positives and negatives and it would subtract them. And then take the absolute value second. That's not going to do it for us because we have to find all of those spots where the integral is negative. And so we can write it this way. You can actually take the absolute value of the function. It's kind of like this. If we had things below the x-axis, we would make them be above the x-axis. Or you can partition it. By that I mean find where the graph touches 0, leave the positive parts alone, take the negative parts and just take the absolute value of that. Okay. So let's take a look at number 1. So here we have a velocity equation. V of t is 10 minus 2t. It is the velocity in meters per second of a particle moving along the x-axis from left to right. Use analytical methods, that means not our calculator, to determine when the particle is moving to the right, to the left, and stopped. Okay, so let's take a look, and for A, we're going to, and we can even do a sign chart for this. First, let's find where the velocity is stopped. That would mean where the velocity equals 0. So where does this equal 0? At t equals 5. So I'm going to summarize this with a little sign chart. Here's 0 because we were told that this starts at 0. And then we'll put a 5 and a 9 on here. So we really have 2 intervals here. If you put a number between 0 and 5 into the velocity equation, is this going to be positive or negative?
Positive.
And between 5 and 9?
Negative.
Okay, this allows me then to answer my question. The particle is stopped when v of t equals 0, and that's at t equals 5. It's moving to the right when v of t is greater than 0, and that occurs on the interval 0 to 5. And it is moving to the left when v of t is less than 0, which occurs on the interval 5 to 9. B, find the particle's displacement for the given time interval. So what should we do? Yep, the displacement is the integral of the velocity. So we're gonna go from 0 to 9 of v of t dt. And since we're using analytical methods, that means we're gonna do this by hand. What's the antiderivative of 10 minus 2t? Minus t squared, right? Because it's a 2 already. And we're going to do this from 9 to 0. So if I put in 9, 10 times 9 is 90 minus 81. And then if I put in 0, it's just 0, isn't it? So 90 minus 81 is 9. So its displacement is 9 meters. And what that means is, well, I don't know what happened, but what I do know is at from 9 to 0, it is going to have a displacement of a total of 9. It's yeah. Now, since I already found this, I'm going to, for its final position for B, so C, for its final position, the final position should be S of 0 plus the integral from 0 to 9 of v of t dt. Okay. And S of 0 is 3, and you're right, we already know this, plus 9. That means it ends up at 12 meters to the, if we're thinking of the origin, we're moving left to right, 12 meters to the right. Okay. Finally, D. So I want to know the total distance. The total distance is going to be the integral from 0 to 9 of the absolute value. The dt can be inside or not, doesn't matter. All right, so here's the deal. This is why this is nice. If the velocity is above the x-axis here, isn't its area going to be still positive from 0 to 5? But negative from 5 to 9. So what I'm going to do is I'm going to break this integral into two parts. I am going to go 0 to 5 v of t dt. I'm going to leave that alone because that's going to be it's going to already be positive. But then I'm going to take this integral and I'm going to find it, and I need to make it positive, so I'm going to then take the absolute value of that negative value. All right. Shoot, am I going to have enough room? I will make it work. Look at all that room I have now. All right. I'm going to move up here, okay? So I already took the antiderivative, correct?
Yeah.
So on this one, I'm going to do 10t minus t squared from 5 to 0. And then the absolute value of the same thing from 9 to 5. Okay. All right, can you guys put in 5 and tell me what you get? Okay. Are y'all good with that? 25, because we'd get 50 minus 25 minus 0. So this is going to give me just a 25. Okay. Then, hold on. When we put in 9, remember we got an 81 minus or 90 minus 81, correct? So it was 9. And then minus, we did the 5 already, it was 25, right? So it's negative 14, but it's positive 14. So we have 39 meters is the total distance that the particle traveled. No, no, no. This is 16. Who told me 14?
Chase it.
Dang it.
That's 11. That's 11. I'm not.
This is negative 16, right?
Who can you think of?
This should be what? 41.
Let Chase take this.
He was going to leave class thinking, haha, I tricked them all. All right. I'm not sure I want to do this one quite yet. I want to do a table, so make sure we covered that. And I think we should also do a trig function. Ooh, this is a good one though. We will get to it. Let's do a table. All right, so remember we kind of have like 4 ways of looking at things. I don't know if you remember this. Verbally I can't really do it. I mean, would be if I asked you to explain it to me. Algebraically would be the way I just gave you if I have an equation. What if I gave you a graph? We've looked at things graphically. Will I ask questions about total distance traveled? Yes, with a graph I will. And then we have like numerically or like a table. So when I have a table, the only way that I know how to find integrals are Riemann sums, right? So I'd have to tell you what kind of Riemann sum I would want you to use. All right, let's take a look. A pump connected to a generator operates at a varying rate, depending on how much power is being drawn from the generator to operate the other machinery. The rate in gallons per minute at which the pump operates is recorded at 5-minute intervals in the table below. Also on page 369 in your textbook, okay? So this is from your textbook. How many gallons were pumped during that hour? Now, like I said, if this was on a AP test, they would say using a left Riemann sum or a right Riemann sum, and they'd tell you how many intervals, or they might say use a trapezoid approximation. So here's what we're going to do. First of all, you always want to still state what you're doing. Even though we're not using an antiderivative, we are trying to understand that if this is a rate times time is going to give me the total gallons pumped if I do the integral of this, okay? So I want to know from 0 to 60, R of t dt is going to give me the total gallons pumped. Now, how do I figure that out? Let's choose to use a trapezoid approximation, okay? So we'll set it up. We can use our calculator for some of the calculation, okay? It looks like I have 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 subintervals. What is, these are equal intervals. What are the width of all of them then? 5. And then the bases are 58 and 60. So 5 times, humor me a second. I'm going to use the kind of the shortcut ways to save us some time. Aren't they going to be 5 for all of them? Are you okay with me pulling that out to the front? Okay. Then the average of these bases is 58 plus 60 over 2. And then I'm going to have to do 5 times 60 plus 65 over 2.